When we move into FFPE and methylation, the gap between mechanical and enzymatic fragmentation becomes very clear. In FFPE blocks, formalin crosslinks and fixatives damage nucleic acids and also poison enzymes. That's why enzymatic shearing often underperforms. The reaction becomes sample-dependent, DV200 stays low, and a large fraction of molecules never make it into the usable 200 net range. Mechanical shearing bypasses that dependency. The energy couples directly into the sample, so even heavily fixed tissues can be driven into a DV200 profile that passes library QC much more consistently, turning "maybe this library will pass" into almost everything passes. In real FFPE cohorts, that translates into higher library yields and much better pass rates across tumor types. Methylation work adds another constraint. We want to read epigenetic marks, not erase them. Enzymatic fragmentation can remove or alter methyl groups, which is why multiple vendors explicitly warn against using their enzymatic modules upstream of methyl CQ. Mechanical fragmentation avoids that interference, so the same BOFU workflow that rescues FFPE performance is also aligned with best practice for methylation analysis. If your customer is doing both FFPE oncology and methylation work on MGI platforms, BOFU gives you one answer to both problems. For ChipSec, the first question is always, can your shearing give us clean 100x500 BP chromatin without destroying epitopes? Here is a simple demonstration on bacterial DNA and cellular chromatin. In each gel, the odd-numbered lanes are unsonicated controls. The even-numbered lanes are after focused ultrasonication. In the controls, you mostly see high molecular weight material stuck at the top of the gel, intact genomes and chromatin that won't immunoprecipitate efficiently or enter the sequencer. After ultrasonication, those same samples collapse into a tight smear in the 100-500 BP range typically used for ChipSec. There is no obvious overshearing into very short fragments, and the pattern is consistent lane to lane, exactly what you need when comparing different antibodies or treatment groups. So the same acoustic approach we use for NGS library prep also delivers controlled chromatin fragmentation, giving labs chip-ready material with predictable fragment sizes and good reproducibility across samples. For MGI customers running ChipSec on your platforms, BOFU simply becomes the natural front end.